In this lesson, you'll learn about the Linux boot process. You'll learn about the BIOS, the bootloader, the Linux kernel, and run levels. BIOS stands for Basic Input-Output System. It's a special type of firmware used in the booting process, and it's the first piece of software that is run when a computer is powered on. The BIOS is operating system independent. Its primary purpose is to test the underlying hardware components and to load a bootloader or operating system. The BIOS performs a POST, which stands for Power On Self-Test. The POST performs some basic checks of various hardware components, such as the CPU, memory, and storage devices. Only if the POST succeeds will the BIOS attempt to load the bootloader. The BIOS contains a list of boot devices such as hard disks, a DVD drive, USB devices, and others depending on the hardware being used. The BIOS searches that list for a bootable device in the order specified. You can change this order by interrupting the boot sequence and entering into the configuration for the BIOS. The key combination used to do this will vary from one hardware manufacturer to another. Once a bootable device has been found, the BIOS will run the bootloader. Typically, the Grub bootloader will be used, but you may run into some older Linux systems that still use the Lilo bootloader. Lilo stands for Linux Loader, while Grub stands for Grand Unified Bootloader. In any case, the primary purpose of the bootloader is to start the operating system. Typically, you will see a message or a series of messages from the bootloader that will allow you to interrupt the boot process and interact with the bootloader. If there are multiple operating systems installed, you can tell the bootloader which operating system to run. You can also tell the bootloader to pass different boot options to the operating system. The initial RAM disk, abbreviated initrd, is a temporary file system that's loaded into memory when the system boots. This file system can contain helpers that perform hardware detection and load the necessary modules, sometimes called drivers, to get the actual file system mounted. For example, if the root file system is stored on an LVM volume or Logical Volume Manager volume, the initrd image will contain the kernel modules required to mount that logical volume as the root file system. Once the initrd mounts the actual root file system, its job is done, and the operating system continues loading from the real root file system. The Linux kernel, the initial RAM disk, and other files needed to boot the operating system are stored in /boot. Here's a listing of the /boot directory for an Ubuntu system. The kernel is typically named VM Linux or VM Linux. If the kernel is compressed, its name ends in Z. In this example, the kernel is VM Linux-3.13.0-46-generic. The initial RAM disk in this example is initrd.img-3.13.0-46-generic. The kernel ring buffer contains messages related to the Linux kernel. A ring buffer is a data structure that is always the same size. Once the buffer is completely full, old messages are discarded when new messages arrive. To see the contents of the kernel ring buffer, use the dmesg command, spelled DMESG. On most Linux distributions, these messages are also stored on disk in the var log dmessages file. Between the dmesg command and the var log dmessage log file, you will be able to see the messages the kernel is generating even during the earliest stages of the boot process when those messages can quickly fly by your screen on boot up. Linux uses run levels to determine what processes and services to start. Each distribution can be configured differently, but in general, run level 0 is used to power off a system, run level 1 is single user mode, run levels 2 through 5 are for normal system operations, and run level 6 is used to reboot a system. Traditionally, run levels were controlled by the init program. The init configuration was stored in etc init tab. To change the default run level using init, you would edit the etc init tab file and set the run level number on the init default line. Here's an example of setting run level 3 to be the default run level. However, init alternatives such as systemd and upstart are quickly taking the place of init, with systemd currently being the most widely adopted replacement. Instead of run levels, systemd has the concept of targets. These targets are roughly equivalent to run levels. To see the list of available targets, look in /lib, systemd/system. You'll notice the run level targets are actually symlinks to the real targets being used. For example, runlevel5.target is a symlink to graphical.target. To change the default run level or target with systemd, use the systemctl command followed by set-default and finally the desired target. Optionally, you can manually create a symlink to the desired target from the etc systemd system default.target file. This example sets the default target to be graphical, which is equivalent to run level 5. With the init system, you can change run levels using the telinit command. Simply supply the run level you want to change to the telinit command. To change the target, the run level equivalent for systemd, use the systemctl command followed by isolate and finally the desired target. Here's how to change to the graphical target. Even though there is a run level for rebooting or target for rebooting if you're using systemd, you can also use the reboot or shutdown commands. Here's how to reboot with init. Tell init space 6. To reboot with systemd, use the systemctl command. Systemctl space isolate space reboot.target. To reboot using the reboot command, simply execute reboot. The format of the shutdown command is shown on your screen. The option to tell shutdown to perform a reboot is -R. You can specify the time to shut down using the hour, minute format. You can also use +n, where n represents the number of minutes to wait before performing the action. Finally, you can use the now keyword to start immediately. You may also specify a wall message that will be broadcast to all users logged into the system. A simple way to reboot the system is to run shutdown space -R space now. To power off a system, use run level 0, the power off target, or the power off command. Again, using init, you can run telinit 0, and with systemd, run systemctl isolate power off.target. Or finally, the easiest way to do it is simply to run the power off command. In this lesson, you learned about the Linux boot process.